16 more people were asked to throw a dart with a different atlatl. Same question as in section 4.1, except for the sample size is different. The average distance that the darts were thrown was 98 yards with a standard deviation of 4 yards. What is the maximum error of the estimate for mu? Alright, so we have S given to us, which is 4. We have N is 16, so now we just need T alpha over 2. My alpha is 0.05. My degrees of freedom are 15. 0.05 and 15. 0.05 and 15. 2.131. Alright, so we plug in 2.131. 4 divided by 4 is 1. So look, the maximum error by estimate is 2.131. Last time it was 1.3. That's almost double. Not really, but still, it's quite a bit more. So this is accurate. Last time we were accurate within 1.3 yards. Now we're accurate only to 2.1 yards. So quite a bit of a difference based on, again, smaller sample size and the fact that we're using the t-distribution. And the last one, 9 people were asked to throw a new heavyweight dart. The average distance that the darts were thrown was 53 yards with a standard deviation of 1.5 yards. What is the maximum error of the estimate of mu with an alpha of 0.1? So everything's the same except for the sample size. So we have our standard deviation, we have our new sample size, and now we have to look up T alpha over 2. So we have an alpha of 0.1 and 8 degrees of freedom. Point 1, right here, and 8 degrees of freedom. 1.860. So we plug that in, and we get 0.93. So on average, these darts will be thrown 53 yards plus and minus basically a yard. Look at how small it was the last time we did it. That's almost 3 times what this is, because the sample size is so small. Alright, so now that we've calculated our e-value, it's exactly the same as what we did last time. We just simply add and subtract e to our x bar. That's it. There's nothing different. There's no T alpha over 2s or anything in this because we've already calculated our e-value. So, same confidence intervals we did last time. 25 people were asked to throw the dart. We had calculated our E of 0.8256. So we're going to add that to our 85 yards and subtract it from our 85 yards. So 85 minus this and 85 plus this. This is our confidence interval. So with the data that I've been given, I am 95% confident that this atlatl can throw these darts between 84.17 yards and 85.83 yards. So the confidence interval is quite a bit wider than it was. Before, when we had a larger sample size and we're using the normal, our confidence interval was a lot tighter. Let's think about it. That's good, right? Because do we want things varying all over the place? If you're taking a drug, do you want to have effects that are way between here and here, or effects that are between here and here? Right? So we want to have a good understanding of how much it's going to fluctuate when we're doing something. And the last one is 16 more people were asked to throw a dart using a different atlatl. The average distance that the darts were thrown was 98 yards with a standard deviation of 4 yards. Constructed 95% confidence interval for the mean distance the new atlatls can throw a dart. So same question, we ended up calculating an e-value of 2.131, and we are going to add and subtract that to our 98 yards. So 98 minus this and 98 plus that, we end up with between 95.87 and 100.31. So I am 95% confident that this atlatl can throw a dart between 95.87 yards and 100.31 yards. Again, much wider confidence interval than what we had before. So the only difference between what we did in this section and what we did in section 4.1 is that we are using T alpha over 2 instead of Z alpha over 2. This is what a typical question is going to look like. Construct a confidence interval for the following population mean. The first thing you have to do is look at its sample size. If it's greater than 30, you use what we did in 4.1. If it's less than or equal to 30, you use what we did in this section.